Alrighty, it's that time. Please stand. Good to say. And let us pray. In nome Patris et Filii et Spiritus Sancti. Amen. Gloria Patri et Filio et Spiritui Sancti. Sicut erat in principio et nunc et semper et in saecula saeculorum. Amen. In nome Patris et Filii et Spiritus Sancti. Please take out your notes. Write down the following. This is what we're going to be chewing at for the next X number of minutes. No pun intended. Okay, plunge slightly into this. So, grab my water. Tell me something about this graph before we even start. Gentlemen. Topic has shifted to mathematics. Tell me something about this graph before we get started. Correct. There's 5 roots. What else? Yeah, Steve.
The dots will be closed.
Correct. They'll all be open dots. What kind of a border will it have?
Dotted.
Yeah. Open dots, dotted border. I don't say dotted line because it's probably not going to be a line. What else is going to be included in this? There are a few other things you can tell me. Yeah.
Well, this isn't like as important, but 12 is the line intercept.
Definitely. The y-intercept is 12. Actually, that's rather important because that's going to be one of our points. I'm going to have you graph this thing, so that's going to include the x-intercepts and the y-intercepts. When you get into calculus, we can get a few more points there too, but one thing at a time. What else can you tell me? Just looking at what's on the board before we even start chewing on it. Yeah.
Well, the range of rational roots.
Is where?
Plus or minus, like plus or minus 12.
Yeah.
The factors of 12.
The roots are going to be somewhere between negative 12 and 12. Definitely. So don't go any further than that.
Well, and the list of rational roots, still plus or minus.
Okay. What is the list of rational roots?
So on top is plus or minus 1, 12, 2, 6, 3, 4. I think that's it.
All over plus or minus what?
1.
1. So tell me about the possible rational roots. Will we have any fractions? No. I mean, not unless you want to count 1 underneath this being a fraction. All the possible rational roots are going to be nice round numbers or nothing. You're welcome. Now, there's one last thing you can tell me about the actual graph. Not even about the polynomial and such, but about the graph. No, specifically, this will involve something. Yeah.
No.
What's going to appear in the graph?
Shading.
Shading. Correct. There's going to be shading. How do you find out which way to shade? I'm actually going to give you a shortcut on this today. But under ordinary circumstances, how do you find out which way to shade? Go. Yeah, plug in any point that's not what? What points would not be a good idea to use? Like, pretend you're like graphing a line with a shading. You pick a point that's not what? Not on the line. Correct. If it's on the line, it doesn't tell you one way or the other. This thing, same thing. Pick a point that's not on the border. And it's going to be a little tricky to find out where the border is, but we'll do that in a minute. Let's launch this thing. Who wants to start me off? Yeah.
Try one.
Yeah. First of all, check this just to make sure it doesn't factor by grouping. Does it?
Well, you could do 3.
Yeah, you could do group of 3, or theoretically you could do 2, 2, 2. Well, what's the catch? When are you allowed to use factor by grouping? When they're proportional. You can do a quick glance. This is 1 to negative 1, negative 9 to 1. Does that look good or bad?
Bad.
That looks bad. If this had been a 1, -1, -9, +9, I would have been interested. That might have worked. Or with triplets, 1, -1, -9. If it had gone 2, -2, -18, then the triplets are proportional. That might work, but this thing is not friendly. What else? Any other question or answer?
Oh, no.
Okay. So what do we, so it doesn't factor by agreement, so what do you want to try first?
One.
Let's try 1 first. Right now, if it doesn't factor and it's this big, you can't do the quadratic formula, it's way too big of a degree. Let's try synthetic division and just guessing. Again, stick to these. I would not guess 5. I would not guess 1/2. I wouldn't guess -20. Stick to that list. 1, somebody give me the coefficients. Okay.
1,
Uh-huh.
-1,
Okay.
-9,
Uh-huh.
1,
Uh-huh.
1, and 12.
Good. Go ahead and run this and see what happens.
Sorry, I'm not prepared with that.
Oh, sorry, go ahead.
Okay, so 1,
Uh-huh.
1,
1.
0,
Okay.
0,
Okay.
-9,
Mhm.
-9,
Uh-huh.
-8,
Good.
-8,
Uh-huh.
12,
Everybody gets all excited here.
12, 24.
Yeah, it does not cancel. So close. Oh well.
I'm trying to use
You don't get insanely lucky all the time. Let's try negative 1. 1, -1, -9, 1, 20, 12. Michael, take this one.
-1,
Not yet.
or 1.
1.
-1,
Good.
-2,
Good.
+2,
Good.
-7,
-7.
+7,
Good.
8,
Uh-huh.
-8, oh my gosh, 12,
12.
-12, 0.
Ding, 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 ding. Congratulations. You get a root. So you've got x equals -1. You've got 5 terms left. Now keep in mind, what power of x did this lead term used to have? I'll take it over.
what is that one?
Used to be x to the 5th. What is it now?
Is X 4?
Yeah, because you ripped out one of the x's. So all of these dropped in power. I just want to keep a watch on that. Because if this drops down to 2, we can stop guessing and do quadratic formula. Or factor, whichever way. I've got 5 terms. That's not going to be factored by grouping material. So I think we need to keep guessing. Any other candidates? Yeah.
2.
Let's try 2. It's a reasonable one. You do not have to start over. Start with 2. Actually, Johnny, go ahead.
Okay, so 1,
Okay.
2,
Uh-huh.
0,
Good.
0,
Uh-huh.
-7,
Mhm.
-14, 6, or sorry, -6,
-6.
-12.
Interesting. Congratulations, by the way. We've got x equals -1 and x equals 2 as roots. I'm going to keep a list on these. X equals -1, x equals 2. That -1 is horrible. How many roots are left? 3. What power is this right now? Yeah, it's 3. It's 1x cubed. Does it look like it might factor by grouping or no? 1, 0, -7, -6. You've got the right number of terms, but they're not proportional. So, Polly, feeling lucky? What next number would you try? Nice easy one. -2, sounds good. Again, no guarantee, but who knows? Go for it. Yeah, please. Uh-huh. Uh-huh.
Sorry,
-2. Almost.
-4.
Yeah, positive 4.
-3.
Gentlemen in the back, please focus. I'm going to be testing you, not me. 6. Oh, congratulations again. So we've got -1, -1, 2, and -2. How many roots are left? Michael, take over.
There are two.
2. Correct. What would you do now if this is down to 1x squared? Sorry, it's on the line. You want to move that thing?
You can, no, it's
Okay.
fine.
Well, translate this for me. It's 1x squared plus what? What is this really?
-2x,
X plus
just
-3, the remainder of 0. Let me write it up here. X squared minus 2x minus 3. Oh, math people. For example, Sophie. Does this thing factor? Maybe. Let's find out. Like what? X plus -3 and x plus 1. Bingo. So if you set those equal to 0, what solutions would you get? Got it. You ever notice anything interesting in that list?
Double root.
There's a double root at -1. Now, double roots are really hard to find when you're guessing, unless you just have an instinct of, I'm going to try a number twice in a row. Normally people don't. They say, well, I already did it, it's done. If it is a double root, if you try the number twice in a row, it will work twice in a row. Does that make sense? If it doesn't work twice in a row, then it's not a double root. We have all 5 roots, congratulations. How do you graph this monster? I will set up the graph, more or less. Direct me. Is there any point you know?
Well, could you go to all the roots and put an open dot on it?
Right. And where's the coordinates of the first one?
So would it just be -1
Yeah, whereabouts is that?
on the x-axis?
On the x-axis, bingo. These are x-intercepts. So -1, I'm going to put an open dot. And by the way, I'm going to put a little mark here. Times 2, it's a double root. And then where else? 2. Open dot. Remember, these are all open dots because it's not solid. Keep going. -2. Okay. And 3. And today I'm going to give you a little bit of a crash course in how to graph polynomials that are big, big degrees. But for right now, there's one more point you should be able to give me, which will actually help us figure out where the graph is going. Go.
I have a quick question.
Oh, go ahead.
So, could you have done the quadratic formula on the bottom?
On this thing?
I know
Yes.
it's easier.
And you would have gotten these.
Okay.
It's totally up to you whether you think it's easier or not. Some people find that easy to do all the time. Some people like factoring. Stuff is
Sorry,
personal
that was
data.
random.
No, no worries. Yeah.
You can get the y-intercept.
The y-intercept, where's that?
12.
At 12. Correct. I'm just gonna fake this and call it 12. I don't want to draw 12 dashes. So, can anybody guess as to where this thing goes? I'm curious if it starts from below or starts from above. Just a refreshment, yeah.
It looks like it starts from above on the left.
It certainly does look like it starts from above. So you're thinking going down, then going up, and through
Oh
here?
wait, sorry, but it's a double.
Aha, good
Sorry.
catch. This is a double root. What does that mean? It's gonna do what?
It's going to bounce
It's gonna bounce. A double root is a bounce. So where does it have to start from?
below.
From below. Yeah, I have no idea how far down it got. Well, it goes down further. But I have no idea. Ooh, guess what I'm doing wrong. Got it. And now what's gonna happen here? Describe what's gonna happen.
It's gonna go back down. It's gonna look like it's going through, but it's gonna bounce. Then go
It's
through.
gonna bounce back up, correct. See why? And it's gonna go up. If I had done it the other way around, I don't know how high that goes, but if I had come from above, you would have had a bounce from below, and it never would have hit here. So we're kind of doing detective work.
So this is coming back down. Since these are all single roots, quick question. You see there's only one space between the 2 and the 3? And that there's like a lot more space between the other 2 roots? Do you notice it goes a lot farther if the space is bigger? Did I tell you the dog on a leash metaphor? Okay, pretend this is a graph. I'm just making this up. So you have 3 roots, one at 0, 1, and 3. Let's just say it's a normal graph. Between 0 and 1, let's say it comes up from here. Do you think this is going to go way, way, way high up between 0 and 1? No, it doesn't have time. It has like here's the dog on a leash metaphor. The dog off the leash metaphor, I should say. You're taking the dog to the dog park. And you say, okay, doggy, I hate to do this to you, but I'm in a hurry. You have 1 minute to run as far as you can, but come back. This is like from 0 to 1. It's 1 minute. Okay, doggy, go. So the dog can run at a dead run for 30 seconds, and then screech, turn around and come back. That's not much time. It's only going to go a little distance and then come back. Now, on the way home, you have 2 minutes. Woohoo. Big spender. Will the dog be able to go farther, or not as far, or exact same amount? Farther. Probably about twice as far. You're probably going to go at least twice as far down, maybe a little more. Does that make sense? If the roots are farther apart, you'll have freedom to go further down. So this little spot, I'm not going very far. This thing was 3 times bigger, so I went, at least 3 times higher. Yeah, question?
So I understand why they're open routes because we don't want them.
Right.
But also, don't open routes mean holes?
They can mean. In this case, they
How am I
don't.
supposed to know?
Oh, okay. A hole shows up in an otherwise solid graph. If everything else is solid and there's just a hole like a rifle shot. If this is all dotted, then they're all basically holes. Yeah. So, if you were to look at this on a computer screen, all you would see is a dashed line. And there's one last thing to do. What are we still missing? Yeah. Shading. Which way do you shade it? How do you find out? Take a point, not on the line or on the border. What point would you like?
At 0.
0, 0 looks good. By the way, is 0, 0 above or below the curvy line? The curvy, now I'm saying it, the curvy graph. Below. Everybody see? It says loopy, 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 but this is below it. So you're either going to shade the entire thing below, or you're going to shade the entire thing above. Let's find out which is which. Plug in a 0. You plug in a 0 for y and a 0 for all the x's. Sophie, tell me what you get after you do that.
You get 12.
What would this be?
Oh, sorry. 0.
Is
0.
greater than,
No.
and that's all there is. In your opinion, true or false?
False.
That's false. So you tested 0, 0 and it came up false. Where are you going to shade?
Away from.
Say it.
Away from it.
Away from it. You're going to shade this. You can go down into this loop. Shade above, go down into this loop.
How is that interesting?
Yeah, I know. Questions? Does that make sense? I am going to show you the shortcut for graphing right now, and a couple of shortcuts for, actually the shortcuts for graphing polynomials, I'll show you tomorrow. Right now, as long as you can find the root and the y-intercept, you can sort of detective your way into finding out whether it comes from below or not. If you get stuck, there are 2 tricks. One you already know and one you do not. The one you already know is you could run plus minus notation on this thing. This region would come up negative, then positive, then another positive, then negative, then positive. That'll tell you whether the graph is above or below. So that could help if you get stuck. The second thing you could do, I'll tell you tomorrow. But for right now, I want to give you a quick shortcut as far as shading. Write this down in your notes. This is the last thing I'm going to have you write down, actually. if an inequality leads with a variable by itself. The shading can be done. I'll just do shading equals follow the sign. I'll need to explain what that means. Go ahead and write it down.
So, sorry, Mr. Cochran, by variable by itself, you mean just x to the fifth rather than like 2x to the fifth?
Actually, not even to the fifth. I'm talking about this.
Oh, sorry.
So if it leads, if the entire formula is led by a single variable with no exponents, no coefficients, no nothing, no anything. Sorry, bad grammar. Then you can use the shortcut. If this were like 2y is greater than, you couldn't do it. You'd have to fix it. If it were y squared, can't do it. But if you lead with a variable by itself, there is something you can do. X greater than means something. X is less than means something. Y is greater than means something. And y is less than means something. Each of these four has a shortcut associated with it. And I bet you can tell me what they are. If x, does x go left, right, or up, down, first of all? Anybody? The letter x. Left, right. If x is greater than, would you expect to go to the right or to the left?
Greater than?
Yeah.
Go to the right.
Goes to the right. That's exactly what you do. You shade to the right. Does that make sense? If x is big, if x is bigger, you go to the right. Somebody tell me what happens when x is less than. Well, shade to the left. This is guaranteed. Somebody tell me about y greater than. Jillian Miller.
It goes
Up. You shade up. And the other one is? Anybody?
down.
Down. Look at our problem. It started with y is greater than. What does that tell us? Stay with me. Y is greater than means what? You shade where? You shade up. And that's exactly what we did. You shaded above the boundary. Alrighty, take out your books, please. We're taking a peek at, I believe there's 3 C's in Charlie. Page 104 thereabouts. The written exercises start on 106. Some of these are, wow, they give you some really small ones. That's kind of sad, but okay.
That's not sad at all.
This-
I'm very happy.
Wow.
Find that not-
Here's the graph of the inequality. I do want to show you, for example, this is not a homework problem, but it's one that's like it. I'm going to do number 12, just as a demo. Homework problem number 12. Absolute value of x is less than or equal to 2. Now this might strike you as strange because there's no y equals. We've been graphing on this xy axis all along, and there's no y on this at all. Quick refresher course. If you have x equals 2, can somebody graph that on a line? Or not on a line, on a plane? Yeah.
Would you just go on the x-axis to 2 and then just draw a vertical line up and down?
Correct. It's a vertical line. What about x is less than or equal to 2? Yeah.
What problems are we doing down there?
I forgot what they were. It is on page, it starts on page 106. Well, the reading is on 104. 1A through 13A odd. Does that make sense? So you do 1A, 3A, 5A, 7A, 9A, 11A, 15A.
1
You
through
don't do
13.
user sheets?
So 1 through 13 odd, just do parts A. Part A for each one. Actually, I'm not even sure there was a part B.
What page?
Yeah, that's a little goofy. What's going on here? Did I just give you useless instructions? Well, basically 1 through 13 odd. I'm not 100% sure what I was thinking with the A's. Because there are no part Bs.
There's like A.
Oh, section A.
A.
Okay, that's very nice, but I think I just spelled. Like, everybody look up here. X is less than or equal to 2. Let me show you real fast. It's a solid vertical line at 2, and you shade to the left. How did I know to shade to the left so fast?
The sign.
Letter by itself, follow the sign. If X is less than, you're shading to the left. Now what do I make with this thing? Well, you can't graph it yet because the absolute value is in the way. I could graph X is less than or equal to 2, I just did. Well, math people, how do you get rid of an absolute value? You split it. Do it. Somebody get in the left-hand side. You can remember the splitting. Stuff inside, equal, yeah.
Sometimes I look up there and I think it says 1 times 1.
Oh, sorry.
No, you can do anything, there's nothing else you can do.
Okay, thanks.
Because it can, anyway. But so X is less than or equal to 2.
Good.
And X is greater than or equal to
Good.
-2?
Yes. The negative side of the splitting flips the sign. I would like you to graph both of these on the same graph. Tell me what that looks like. X is less than or equal to 2. That should look like this. Solid vertical line over here. Don't shade yet. There's a reason why. Don't shade yet. I'm just going to do a little reminder arrow. It's going to shade that way. Why am I doing that? Because there's another part. Can somebody do this for me? Describe verbally. X is greater than or equal to -2. Who can help me out with that? Yeah, go.
So you have -2,
Okay.
another vertical line,
Solid or dotted?
solid,
Solid. And which way do you shade?
in between two.
Yeah, to the right for this one. Did we see what is to the right? X is greater than? Can you tell me where the overlap is? And I think you already said it.
Just in between.
You shade in between. Exactly. That's the problem. There is a shortcut even beyond that, but I'll show you that tomorrow. We feeling okay on these? Okay. Some of these are good old-fashioned standard form, like at number 3. So just do the Shorthand method or whatever you like. Solid or dotted, whichever you need. Shade the appropriate direction, yada, yada, yada. And that is all I have for you.
What would it be for number 1?
Yeah.
Number 1.
Yeah, 'cause-
Y is greater than or equal to X. Believe it or not, that is slope-intercept form. If you fill in some missing numbers.
But there are no numbers.
There are, but they're invisible.
1.
There's a 1 in front of the X, plus what? Plus 0 at the end. That should help. Okay? Go to it. Call me over if you get stuck. Otherwise, enjoy. I'll try and keep this computer in submission. Like I've done 20 times
Should you
before.
end the video?
Oh yes, bless your heart, thank you.
Bye, Julia.
Oh, thank you very much, yes.